Hello students, welcome to Physics Classroom. This is Vaibhav, your physics teacher. Well, this is the day 4 of the physics preparation for Olympiad exams. So this is a day 4. In today's lecture, we will discuss about the multiplication of vectors. Okay, in the last lectures or first 3 lectures, we discussed about the different types of vectors, how can we add the vector, how can we subtract the vector, different types of vectors we have discussed, and we have done a lot of questions. You can check my previous videos also. Okay, so in the today's lecture we will discuss about the multiplication of vector. Okay, so you all know about the vector means, okay, magnitude as well as magnitude and direction. Okay, means if I take the vector a, it's like that. Okay, and this vector having some magnitude, it's like that 5, and there is a vector, the direction is east. Okay, so this is the east is the direction and magnitude is 5, right? It's like that. So this is the magnitude and this is the direction. If I multiply, this is the first type of a multiplication. If I multiply this vector with the, okay, any scalar quantity, okay, the first type of multiplication is multiplication of vector by scalar quantity. Just like that. Okay, you all know the size of this arrow of this vector, it depends upon the magnitude. Okay, if there is a small magnitude, there is a small size of vector. Okay, if there is a large magnitude, there is a large size of a arrow of vector. Okay, so if I multiply this vector with any scalar quantity, multiply with, I am taking 10, right? This is a scalar quantity. So what happened means, so this vector will become, this is the multiply of vector of magnitude multiply this one, means 5 into 10 is 50, with the direction will be remains constant, means direction is remains constant, just like that. Okay, but if I multiply this vector with negative scalar quantity, what happen? Okay, means we have to multiply with this vector. Negative scalar quantity means the direction will get reversed. Okay, just like that. If I take, this is the vector a and this is the 5, the magnitude of vector is 5, multiply 5 means it will be 25, but the direction will get reversed, it will be west, just like that. Okay, so how can we write this? This is the vector a will be 50 magnitude in east direction, and here the vector a will be 25 magnitude in west direction, because we multiply this vector with the negative scalar quantity, so that's why direction of vector will get reversed. All right, now if I do, okay, so I have two types of vectors. Okay, means I am taking vector a is ax I cap plus b, or ay j cap plus az k cap, and I have another vector bx I cap plus by j cap plus bz k cap. And this is the components of the vectors in a different in the Cartesian form. All right. So we have two types of multiplication of vector. The first one is the dot product, and the second one is cross product. The dot product we can also known as, this is the scalar product also, and the cross product is a vector product. Okay, so we will see one by one. So what is the dot product and what is the vector product or the scalar cross product? Okay, see, the first multiplication of vector is dot product. Okay, the dot product, or we can say this is the scalar product also. Okay, with the name of these product we can guess, so what will be the resultant, what will the result of the dot product. Okay, means we will give, if we multiply the two vectors, so we will give the only scalar quantity. Okay, which is not in a vector quantity, may they are not any Cartesian form, they don't have any the directions, we will get only magnitude. All right, so how can we get the magnitude of the dot product? Okay, means if I take the c vector or the magnitude of c vector, it will be a b cos theta, just like that. Okay, or means, and the c is nothing but a dot b. This is the representation of a dot product. Representation just like that, a dot b. Okay, so with the help of these, okay, we can get the magnitude. So if I take the example, then that a vector a x I cap plus a y j cap plus a z k cap, and we have the another vector b vector bx I cap plus by j cap plus bz k cap. So we want the scalar product or the dot product of vector a and b, means this is the c vector or the magnitude of the resultant vector, or we can write a dot b will be a b cos theta also. And how can we write, this is the a dot b, means here we have to multiply the magnitude in the Cartesian form in a particular axis. Okay, it's like that, ax bx plus ay by plus az bz. So we will get the only magnitude of the dot product in the Cartesian form. So this is nothing but the Cartesian form. Dot product. All right. So how can we do that? So while during the Cartesian form dot product, we have to remember some particular points. It's like that. The remember points, just like that, means if I multiply I cap, so we will get 1. Okay, if I multiply the same j cap, multiply j cap, we will get 1, and k cap dot k cap, we will get 1. Otherwise, if I multiply I cap dot j cap, we will get 0. Then j cap dot k cap, we will get 0. Then k cap dot I cap, we will get 0. If the same axis, then we will get 1. Other axis, we will get 0. This is the, we have to remember the sum points while the dot product. Okay, and with the help of dot product, we can get the angle between the two vectors also. Okay, so how can we write the first one? So the second one is the angle between two vectors. Select it. Okay, so how can we get? See here, the a dot b, okay, means a b cos theta, right? Can I write just like that? Cos theta is a dot b divided by a b. So this theta is angle between vector a and vector b, just like that. So with the help of this, we can get the angle. All right. So if I get angle, means we can get the resultant vector. Okay, or we can get, means if I want to project the one vector on the another vector, we know the what is the direction of the other vector. We can find the direction of the other vector also. Just like that. Okay. The third topic is projection of one vector on another vector. How can we project? Okay, the simple thing, I am taking the two vectors. Correct, just like that. This is the vector b and this is the vector a. Okay, so what happened? I have to project the vector a on vector b. Okay, see, and just like that, here only we can project. Okay, so this is the angle between a and b. Okay, so can I write this is the vector b? Okay, right, means we have to find the direction of vector b first of all. Okay, so how can we get then? Means here I am taking the vector b or the direction of vector b, it will be a cos theta, just like that. Okay, then if I want to project this vector a, we just find the cos theta a dot b divided by a b, just like that. Okay, means a dot b divided by a b. Alright, means a and a will get cancelled. Okay, then here A dot B divided by magnitude of B. The projection of vector B or vector A on B will be A. So this is equal to B vector divided by magnitude of B. This is called unit vector of B. Just like that. Okay. Means if I want to project on B, the projection of A on B vector means we have the magnitude of A and direction of B vector. Okay, so this is the magnitude and this is the direction. It's like that we can project the one vector on the other vector also. All right, then again, so we have to remember some points also. The remember point, okay, I just noted in the last slide. Okay, means I dot j is 0, then j dot k is 0, then I dot k also is 0. Okay, means we can give some points. Okay, if the two vector, the first point, if two vectors are perpendicular to each other, then their dot product will be 0. Okay, and the second point, just reverse of this. Okay, means if the dot product of two vectors is 0, then these two vectors are perpendicular to each other. Okay, means if the two vectors are perpendicular to each other, then the dot product of these two vectors will be 0. Otherwise, if the dot product of the two vector is 0, then these two vectors are perpendicular to each other. Okay, so these two statements is nothing but law of orthogonality or perpendicularity. Okay, means this is called law of orthogonality or perpendicularity. Okay, so you have to remember these 2 points always. Now the second multiplication is the cross product. Okay, this is also the very easy product. It's called vector product also, right? Vector product means we will get magnitude as well as direction. Means the resultant of this multiplication of the two products, okay, we will get in a vector form only. Okay, just like that. For example, we are taking one example. Okay. So first of all, means if I take this cross product C is A cross B. Okay. So this is the vector product, or this is the vector product resultant. Okay. And how can we get the magnitude of the vector product A cross B? Okay. So it will be A B sine theta. Right. With the help of this, we will get magnitude also. All right. But in the Cartesian forms, in the Cartesian form, cross product. So how can we get? Okay, with the help of a right hand thumb rule. Okay. So what is the right hand thumb rule? If I take, so here, this is the y axis, this is the x axis. Okay. This is the negative y and negative x, and this is the z axis. All right, just like that. So if the unit vector is moving toward the x axis, it will be I cap. If the unit vector is moving towards the y axis, it will be j cap, and it will be moving toward the z axis. This is the k cap, just like that. Okay, all are perpendicular to each other, right? Just like that. All are perpendicular to each other. Okay, so you have to remember the one point. The points you have to remember. So how can we get? So I am doing triangle I cap, j cap, and k cap. Okay, means I am taking a cross product of I cap and j cap, so we will get k cap, positive k cap. Okay, means if you are moving in a clockwise direction, we will get positive values. If I am moving, okay, in an anti-clockwise direction, we will get negative values. Okay, so how can we write? Just like that. Okay, so I cross j, we will get k cap. If I take j cross I, sorry, j cross k, we will get I cap. Okay, k cross I, we will get j cap. K cross I, we will get j cap. Okay, otherwise, if I'm moving j cross I, means we will get minus k cap. Okay, I cross k, we will get minus j cap. Then k cross j, we will get minus I cap. Okay, just like that. Otherwise, if I take I cross I cap, we will get 0. Then j cross j, we will get 0. Then k cross k, again we will get 0. Okay, so we can find with the help of right hand thumb rule also. Okay, means the right hand thumb rule. Okay, means simply, okay, the simply means we are taking the one palm on the origin, all right, just like that. And if I rotating my palm, okay, with the thumb is moving in the upward direction. If I rotating my palm from I to J cap, okay, I to J cap, and my direction of thumb will get the resultant vector or the multiplication of both axes. I cross J will get positive K, right? Okay, then again J cross K, okay, J cross K will get positive I, right? If I take the, it's like that, if I am rotating for J cross I, means we have to rotate from J to I. J cross I cap, we will get negative K cap. It's like that. Okay. J cross, where? J cross I cap. Where is that? J cross I cap, we will get negative K cap. Just like that, we have to do like that. Okay. So with the help of this, we can, okay, conclude the one statement, okay, means this cross product is not commutative also, means A cross B, okay, which is not equal to B cross A. It should be equal to A cross B, it will be minus of B cross A also, which is not commutative. Okay, it will be distributive, but it will not be commutative. Okay, so this is about the cross product. Okay, so now we will discuss about the how can we get the values within the Cartesian form. Okay, there is a small method, a simple method we will get. Okay, so this method we will get the multiplication, easily multiplication of the vectors, okay, the two vectors in the cross product. So this is called matrix method of cross product. Okay, means if I take the A vector, means ax I cap plus ay j cap plus az k cap, just like that. I am taking the another vector B, this is the bx I cap plus by j cap plus bz k cap. Okay, now I want to take the C vector will be A vector multiply B vector or the cross product of B vector. Okay, so how can we get? We all know about the matrix or nothing but, so we have to rearrange this all these things in a particular manner. Okay, means it's like that. I am taking, see, all right, this is called matrix. Okay, means we are taking a two lines is called, right, matrix. In the form of matrix we have to rearrange things like that. I, j and k, I, j and k, in the similar manner we have to arrange these things. Okay, now we are taking the magnitude of the A vector in a particular axis, okay, in a particular direction. It's like that. Ax with the j cap, ay with the k cap, az. Okay, now we have to arrange for the B vector also. Bx, okay, then by, then bz, just like that. Okay, we have to arrange these things. Okay, then there is a one simple things we have to find this magnitude of this matrix. This is called determinant. इसको क्या बोलेंगे हम? Determinant. Okay. See, we have to find the C vector is nothing but determinant of the matrix. Okay, so how can we find this matrix then? Determinant of matrix. We have to take only black color now. Right. So first of all, we have to take I cap. Okay, and we have to leave this row of I cap and column of I cap. Then the remaining these things, okay, AY, BZ, AZ and BY, we have to take the cross multiplication. Okay, means AY multiply BZ, AY multiply BZ minus AZ multiply BY. Just like that. Okay, AZ multiply BY. Now in the second case, okay, if I am taking this one I cap, okay, now I am taking the second case for the J cap. Okay, we have to take the alternate positive, negative, positive, negative. So I am using the negative sign with the J cap. If there is another column, so यहाँ पे भी we are taking negative column, but there is no column, so that's why we are taking, this is the positive value and positive sign, this is the negative sign, again this is the positive sign, means I am taking here positive sign, I am taking the negative sign, means negative minus J cap. Again we have to leave the column and row of J cap, and we have to take the remaining four values. It's like that: AX, AZ, BX and BZ. Means AX minus BZ multiply BZ minus AZ multiply BX. Again the K value, okay, or the K column will be the positive, so that's why I'm taking the positive K. Again we have to leave the column and row, okay, so we have to take these four values, means AX multiply BY minus AY multiply BX. So just like that we will get the determinant of matrix. Okay, so we can write AYBZ minus AZBY I cap. Okay, now I am writing the negative sign in the under the bracket, then AZBX minus AXBZ K cap, then AXBY minus AYBX J cap. So this is nothing but C vector or product of vector A, cross product of vector A and cross product of vector B. This is our solution. Okay, so in this way we can find the Cartesian forms cross product also. Okay, just like that. Okay, hope you have understood these things. Okay, so this is all about the vector quantities. Okay, from the we have completed this the vector topic in the total 4 lectures, day 1, day 2, day 3, day 4. Okay, you can watch my videos from the day 1 also. You will get a detailed idea about the what is the scalar quantity, what is the vector quantity, what are the different types of vectors, how can we represent vector, how can we represent in the Cartesian forms, how can we add the vector, how can we subtract the vector, how can we multiply vector. All these things we will get. Okay, because the use all students are from the 8th, 9th and 10th standard, right? Okay, you don't know, you don't have any the idea about the vectors. So first of all, just go through the all 4 days of our classes. In the next class we will discuss about the trigonometric ratios and angles. So this is the most important topics you have to understood, okay, because there is a lot of things we have to use the such type of mathematical tools in the physics to understand the physics. All right, so hope so. Okay, so let's meet in the next day. Okay, in the upcoming classes we will discuss the lot of things. Okay, so stay tuned, please like, share and subscribe. Bye.